Hello, this is Mohammed Shamila from Group 1. In this project, I have created an environment. In this environment, there is a floor, some walls, and a few objects. For the objects, I have created the object first from the base nodes. I have selected a transform, uh, and then in the transform, in the children part, I have selected a shape. Okay, inside the shape, in the geometry, I have added any type of shape. In this case, I have selected the cylinder. In the appearance, we have to add the appearance also. The appearance will be uh, let's add the appearance. Okay. Inside geometry, let's select the parameters. Let this be 0.5 and the radius be 0.2. And then to actually view the object, we have to add the materials. Okay. Now let's translate this a little bit upward and over here. Okay. Now we have to change this into a solid. Okay. Now we have to add the collision through bounding object. Uh, we have to select the same shape as before, which is a cylinder in this case, and have to add the physics as well. The physics has been added. In the bounding object, we have to choose the parameter as before, which is 0.5 for the height and for the radius 0.2. Okay. Now if you start the simulation, the object doesn't follow because of the collision added, and because of the added physics we can actually apply force to it. uh, this is how I have added all the object and created the floor and the walls. For the floor, I have added a box of box shape, and that is how I did it. Thank you.
Hello everyone, I'm Rajesh Majumdar, and in my CSE 461 midterm project, my task to create the body of the robot with the hinge joints. So now let's get started. So here is my robot which I've already built, and here is the four hinge joints of my robot. So I would like to show how to create this robot, and I would like to show some sub steps of it. To create the robot, now we are going to the adding the base nodes, and in the base node section, I have to add a robot. So I have added already a robot, and here we can see there is a super class of this robot, and in the super class of the robot in the children section, now I have to give it as a shape. So I'm going to the base node, and after the base node I have to select the shape. Now I have selected the shape here and add it. And after selecting the shape, in the shape I have to give it as an appearance, and in the appearance mode I am going to the base node, and in the base node I have selected appearance and clicking on the add, and the appearance has been added. And even in the geometrical purpose, for to give it as a box shape, I have to select it as a box, and after that I have added the box. So after using the translation mode, we can simply uh, drag the object, and now we can see the object has touched the floor because there is a shadow. From the shadow we can determine it. And after that, in the robot one section, we can simply use adjust the size here in the geometry box. So we have to go to the size, and in the side of step we are changing the xyz coordinates. We can simply adjust the size. So here is some demonstrated example. So it was a subset of my building the robot's body. As I have limited time, so I have to explain the hinge joints. Now I'd like to explain one hinge joint, and the same process I have also built the other three rest of the three hinge joints, total four hinge joints. So now, yeah, I'm like to go to the main robot superclass, and the main robot superclass, here you can see I have added the hinge joint, and in the hinge joint section there is a joint parameter hinge joint. So I have also added it, and in the device section I have added this rotational motor. Okay, and in the endpoint section I have made it solid, and I made it solid, and made it solid, and I have in the endpoint and children section I have given some no, sorry, I have given its appearance. It's a PBR appearance, and after that I have added the geometrical cylinder, and given it as given the shape as it is the geometrical as cylinder mode. And after that I have given their height and the radius, and after that I have added the bounding object. And finally, I have added the physics to have the real life experiences. The object can have the mass. Object can have the mass, gravity, and for and finally, I have added some extra other components such as the distance sensor and the camera and the GPS. So so thank you for watching. So my next element will present the next steps of this 461 midterm project. Thank you.
Hello everyone, I am Raisa Hassan Bushra and I'll be talking about the code implementation part of our project. We have used C++ language for the controller and for the camera. So from the simulation we can see that our robot is working properly. It's moving very smoothly, and whenever it gets an obstacle on its path, it turns around and it can identify obstacles with its sensors. So from here, from the code section, we can see that we have defined the time step as 64, and then we have initialized our wheels in this portion, and this is the camera portion. We have enabled the time steps here, and we have also enabled the time steps in our distance vectors. And in this portion, our robot is identifying any obstacle in its path, and whenever it gets an obstacle, it gets turned around. And this is how our robot is working. If we zoom in our camera a little bit, we can see that whenever it gets an obstacle, it's turning around and it's working very smoothly. That's all from me. Thank you.
Assalamu alaikum, this is Joy Kormukar and I have worked on the object recognition part of our project. For object recognition we have to at first set up the camera, and for that we have to do the camera coding. And so these three lines are the camera codes, and after doing the camera codes we have to work on the object recognition. So for that we have to go to the camera folder of the robot, and then we have to enter in the recognition folder. In recognition folder we have to set these things up. The max range is 100, which shows that our robot can recognize any object within the range of 1 to 100. Max objects are -1, which ensures us that our robot can detect infinite number of objects. Occultation is true, which means if a object is behind another object, our robot can easily detect them. Frame color is red over here, so our robot will do a framing of red rectangular shape around the objects. So after doing this setup we have to work on our code, and we have to write this piece of code over here. We have used time step over here. So after every 64 millisecond our camera is recording a picture, and after recording a picture it can recognize that thing. So if we start the simulation, you can see that here the red rectangular boundaries around the objects, which shows that our robot can easily find out the objects now. So that's it from our part. Thank you.